great pleasure to welcome Professor Mary Rinella to the studio tonight. As you very well know, Mary is a professor of medicine at Northwestern University Medical Center and is going to discuss some of the presentations that were given today on non-alcoholic fatty liver disease in relation to clinical outcomes and staging. So good evening, Maru. So could you tell me which abstracts you'd like to highlight, please?
Absolutely. Thank you, Phil. So there were really several abstracts today that were that were interesting, particularly in that they highlighted mechanisms through which patients with NAFLD can be risk stratified. So I'm going to highlight initially abstract number 96, 100, and 159 because those sort of broadly touch on that theme. The first one is a Swedish population study by Hannes Hagström and colleagues. And here, importantly, they show that serial measurements of FIB4 can be useful to identify those at risk for disease progression. And basically what they did is they looked at 2 time points within a 5-year period. And then they also assessed transitions from low and intermediate to high risk in order to see how well they correlated with liver-related outcomes, so progression of cirrhosis and decompensation and such. So what they found was that a 1-unit increase in FIB4 was associated with an adjusted hazard ratio of 1.81 for severity of liver disease, and then also importantly, a transition from a low or intermediate into the high risk was associated with an adjusted hazard ratio of approximately 8. And then, of course, those who had had high readings at both time points had the highest hazard ratio of 17. So I thought this was really interesting. I think it's important because it's obviously something that can be used with limited resources. I would say my only major concern with this is that half of the 580 or so people who had an event were in the low group on both occasions, which is interesting because generally FIB4 is known for its high negative predictive value. And I suppose just speak to the limited accuracy of these methods, but nevertheless, it really, I think, is an interesting and important way to look at populations and identify those at risk despite these limitations. The next abstract that I thought was interesting along these veins is one by Nagachalasani from the NASH CRN dataset. And here they looked at transannual elastography done at more than one time point to basically assess the risk of correlate with the risk of progression increases in liver stiffness. So they looked at, as I said, longitudinal changes in liver stiffness based on baseline fibrosis stage, and then the time to and the factors associated with developing liver stiffness-defined cirrhosis, which they set at greater than 14.9 kPa. And those that, of course, didn't have cirrhosis on their initial VCTE. So what was, I think, important from this abstract is that meaningful changes in liver stiffness were only seen in those in the F3 group. And they did identify an annual cirrhosis progression rate of about 7%. So this, I think, lends support to the notion that changes in transannual elastography can be useful to identify those with progression, and it also can be used to identify or monitor disease progression over time, which is very important clinically, especially in those with F3 that are a particular high risk for adverse liver-related outcomes. Moving on to the next one that's along these is a bit more of a nuanced assessment of risk, and that would be abstract 159. And this is a really interesting abstract. So it looks at the identification of a transcriptomic signature that might predict fibrosis progression using the Eurodelta cohort. Here, they looked at those that had had 2 biopsies, and then they looked at several things. In addition to histology, they looked at PNPLA3 and TM6SF2 genotypes, as well as transcriptomic data, and then a selected amount of protein level data using immunohistochemistry. So interestingly, of the factors that they looked at, only diabetes was independently associated with fibrosis progression, and that was fairly modest. There was specifically no histologic feature, and interestingly, carriage of PNPLA3 at risk allele was also not predictive. But what was interesting, I think, about this was some of their findings on transcriptomics. Perhaps not terribly surprising, were the finding that signatures associated with extracellular remodeling or apoptosis were abnormal and predictive, but that metabolic metabolism related genes such as AASLD 17B13 were, and I think that's certainly telling and important.
Okay, no, that's great, Mara. So we've got different strategies for looking for disease progression in sort of primary care as well as the hospital sector. So on the basis of these studies, you mentioned some of the caveats, but what other clarifications do you think we need before we're in a position that we can recommend these for widespread adoption?
So are you referring to the transient elastography and FIB4 or the more... Yeah.
Well, I will start with those two first, and I'll come on to the transcriptomic one to see which one you think, what out of there really excites you.
Mm-hmm. Yeah, so as far as what we can use now, I do really think that we are at a point where even with the limitations of FIB4 and transient elastography, I do think they get us quite a bit further than we would otherwise be in order to identify those at risk. But again, the most important thing that these can do for us is they can identify those that really aren't at risk, because of course the majority of people with fatty liver disease are not going to develop cirrhosis, and it's important to sort of declutter, in a sense, our clinics and our attention away from those and towards those that are a bit higher risk. And I think using a combination of FIB4 and a liver stiffness measurement is a reasonably good way to get to those patients, high-risk patients.
Okay, so just to come back to the study, the transcriptomic study, which elements of that most excite you, and which do you see potentially translating into clinical practice?
Yeah, so I think the most exciting, is the HSD17B13, largely because it's been shown to track with, ALT, with development of cirrhosis, and inflammatory injury. So I think that it's a plausible target that is also being leveraged from a therapeutic standpoint. So that's why I think that was particularly interesting. Because I think it's something that we could modify in the future to sort of improve or reduce injury, so to speak.
Okay, no, thanks. So tell me, are there any other abstracts that you'd like to flag up that you've seen today?
Yeah, so I thought a couple were interesting. I'm going to mention AS102, which was the abstract that looked at convolutional neural networks of H&E stained biopsy images. And I think this is important for a couple of reasons, because as I think we all know, histology, it's of course the reference standard still at this point, but it really has many limitations. First of all, it's using an ordinal measurement scale to describe a linear process, which I think is limiting. There's also, of course, significant disagreement or lack of concordance sometimes between pathologists, even expert pathologists, and even sometimes within pathologists, which makes reliability somewhat challenging, particularly once you disseminate interpretation into the real world away from the handful of highly expert NASH pathologists. So I think histology is an issue, and thereby is an issue with respect to how we measure meaningful change in studies. So this is an example of the way we could use artificial intelligence to sort of improve or reduce some of the noise that we see in histologic interpretation. So here, this group used data from the Gilead data set. So these are from 5 studies, simtuzumab and selonsertib trials put together. And they basically developed CNN-derived scores. And they found that these were highly correlated with Ishak stage, and which is reassuring. Also steatosis, ballooning, and lobular inflammation at levels that are a little bit better than we might see between one expert pathologist, and another. But I think what was most interesting about this was that they compared these CNN-derived scores with NASH biomarkers, such as ELF and its components, where there was a very significant correlation, as well as other things such as insulin levels, HOMA-IR, and monocyte leukocyte ratio. So these are, it sort of helps us cross over and see a more direct association between these computer-derived models and relevant, we think, relevant biomarkers that may predict outcomes down the road. Now, I guess the biggest issue with anything that uses this particular technology is the accuracy is really going to be dependent on, the data set that you trained, the model on. And in this particular case, this was really derived from a highly enriched F3, F4 population, which may make it a little bit less applicable to a broader population. That would be the major, I think, reservation I would have with this particular abstract.
Okay, thank you very much. So I think there was one more abstract that you'd mentioned that you were wanting to refer to. I think it was the one on
MRE. Yes, exactly. So the last is a ASO 97, and these are data from Rohit Lumba's group from UCSD. And basically what he did is he performed a cross-sectional analysis of his prospective cohort as sort of a test cohort, and then he validated it with a Japanese cohort. So here, I think not surprisingly, we saw very high diagnostic accuracy using MRE to detect the relevant population of F2 or greater. And so not only are these the population that are going to be targeted for clinical trial recruitment, but also likely are going to be the target population for therapeutics as they become available. So here, again, very high area under the receiver operating curve of 0.91. And then, of course, compared to FIB4 alone, which we know is lower than this at about 0.8. But then when these two were combined, there was a superior accuracy with respect to identification of that key F2 or greater population. Positive predictive value here was 89.5 in the UCSD cohort, and it was still significant, albeit a touch less so in the Japanese cohort. So I think this is really important. I think, again, the major limitation here is access to MRE. And so maybe, I don't know if, Phil, you have any questions or you want to speak to that a little bit, or I'm happy to give my opinion on that as well.
Well, I think there's two final questions I wanted to pick up in the remaining few minutes. One was, what do you think we will be using? And I guess this talks to the regulatory standards. What do you think we will need to use to recruit patients into trials in 3 to 5 years' time? Do you think we'll be still restricted to biopsies, or do you think we'll be using non-invasive markers?
Yeah, so I think ultimately for trials, that's where I think the biopsy will lag, and we'll be using biopsy still a bit more. I think we will be using the clinical prediction rules and liver stiffness, and I actually think that transcranial elastography is sufficient for that particular use. With respect to how we may be using biopsies in the future once we have drugs approved, I think this is largely going to depend on the cost, where these drugs are priced, and I think that will correlate directly with how many barriers are put up. Additionally, I think it's important to note, at least from the regulators that at least payers that I've spoken to, it's going to depend on what we write in our guidelines and, of course, how the label reads for these developing compounds. But I really do not think biopsy will be required.
Yeah, no, I think that's spot on. Well, listen, thank you very much, Mary, for a fantastic session.